कि अगर है शौक मिलने का तो शरण ले सत सद्गुरु की क्यों, तरीका याद से मिलाने का उन्हें खूब आता है। इन्हीं पंक्तियों के साथ मैं अपनी बात को विराम देता हूँ और आगे के कार्यक्रम संचालन के लिए मैं अपने सहपाठी श्री आशुतोष पांडे जी एवं उनके सहयोगी आईसी सिंघल जी को आमंत्रित करता हूँ कि वो आए और आगे के कार्यक्रम का संचालन करें।
Thank you, Ashik. Good afternoon, respected director, coordinator, CSIR-AMPRI, all faculty members, staff members, my dear colleagues. I, Ashutosh Pandey, with my co-host, RC Singer, welcome you all for the celebration of Teachers' Day on behalf of all CSIR-AMPRI students.
Today, we have gathered here to celebrate this wonderful day so that the best profession of the world can be respected. On this auspicious day, we would express our gratitude to all those who contributed by tone and molded us what we are today.
I would request today's chief guest, Professor Abhish Kumar Srivastav, Dr. Raju Khan, Dr. Alka Mishra, to come on the dais and take their respective seats.
I would request our chief guest, Professor Abhish Kumar Srivastav, to allow me to start the program. Sir, shall we? Thank you, sir.
Let us start the program. I would request our all the dignitaries present on the dais for lamp lighting. Also, I would like to call Mr. Ashish Kumar Chaturvedi for Saraswati Vandana.
क्या सबको करेंगे दीप ज्योति परम ज्योति, दीप ज्योति नमस्तुते, दीपो हरत में पापम, दीप ज्योति नमस्तुते, शुभम करोति कल्याणम, आरोग्यम सुखसंपदाम, दुष्ट बुद्धि विनाशाय, दीप ज्योति नमस्तुते, नमस्तुते नमस्तुते, दीप ज्योति नमस्तुते। या कुंदेन्दु तुषार हार धवला, या शुभ्रवस्त्राविता, या वीणा वरदंड मंडित करा, या श्वेत पद्मासना, या ब्रह्मा देवै सदा वंदिता, पातु सरस्वती भगवती निःशेष जात्यापहा।
Thank you, Ashish.
मैडम हो गया
अक्षर 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 हमें सिखाते, शब्द शब्द का अर्थ बताते, सभी डांट से सभी प्यार से जीवन जीना हमें सिखाते हैं। With this, now I would like to request Mr. Kumar Srivastava.
Now I would like to call Mr. Rahul Arya to present the award to Dr. Rajiv Khan, Coordinator, CSIR-AMPRI. Now I would like to invite Ms. Priyanka Prabhakar to present bouquet to Dr. Alka Mishra, Nodal Scientist, CSIR-AMPRI. आयुषी, हम टीचर्स डे क्यों मनाते हैं?
सर टीचर्स डे क्यों बनाते हैं ये तो मुझे नहीं पता, मतलब मुझे पता है लेकिन ये बताएंगे हमारे शशांक सर थोड़ी देर बाद। लेकिन मुझे ये पता है कि आज हमारे पूर्व राष्ट्रपति डॉक्टर राधाकृष्णन जी का बर्थडे हुआ करता था, तो आज हम उनका बर्थडे ही मना रहे हैं शायद।
तो क्या तुमने कभी कोई बर्थडे सेलिब्रेशन विदाउट केक कटिंग देखा है?
नहीं, देखा तो नहीं है। So it's time to cheer up with the cake cutting. I will request all the dignitaries to please allow me for the cake cutting ceremony. Mr. Rakesh Raj, I request you to bring the cake on the stage, please.
I would like to call Ms. Varsha Parmar for the welcome address.
Very good afternoon to everyone present here. Respected Director, CSIR-AMPRI, Coordinator and Nodal Scientist, ACSIR-AMPRI, scientists, technical staff, and all my dear colleagues. A very warm and heartfelt welcome to all. As we all know, today we all have gathered here to celebrate and pay kind heart tribute to our respected teacher. It's the privilege to welcome our beloved teacher on this special occasion. Let us all appreciate the endless effort of all our teachers with a huge round of applause. I would like to start by wishing all my respected teachers a very happy Teachers' Day. Teachers' Day is commemorated on 5th of September on the birthday of the greatest educationist and the scholar of nation, Dr. Sarvapalli Radhakrishnan Sir, who was independent India's second president. And this occasion of Teachers' Day began in 1962. I would love to extend my heartiest congratulations and gratitude to every teacher on behalf of all CSIR-AMPRI students for always being a guiding light and ray of hope in our lives. The scientists of CSIR-AMPRI are not only an excellent researchers, but they are also an outstanding teacher. They not only teaches us different subjects, but they also mold and develop our overall personality and character. They are the real gurus who teaches us the technique to exploring the reality of our inner being. As it said, life is the greatest teacher of all. Life teaches us the art of survival, and teachers play a very important role as they taught us how to overcome with the failure. Lastly, I will compile my welcome address with this poem. वो कौन सा है पथ जिसे देता है जहां सम्मान, वो कौन सा है पथ जो करता है देशों का निर्माण, वो कौन सा है पथ जो बनाता है इंसान को इंसान, वो कौन सा है पथ जिसे करते हैं सभी प्रणाम, वो कौन सा है पथ जिसकी छाया में मिलता है ज्ञान, वो कौन सा है पथ जो कराए सही दिशा का पहचान, गुरु है इस पथ का नाम, मेरे सभी गुरुजनों को शत शत प्रणाम. थैंक यू. कहते हैं गुरु का कोई गिफ्ट नहीं होता, गुरु से ही हर दिन होता है. With this, I would like to call Mr. Shashank Srivastava to say a few words on the importance of teachers and the Teachers' Day.
A very good evening to all of teachers. As we gather today to celebrate the occasion of Teachers' Day, I would like to thank every teacher who has been guiding us, inspiring us, and making us what we are today. Teachers' Day celebration started in the remembrance of a prominent Indian scholar and politician, Dr. Sarvepalli Radhakrishnan, who served as the second president of India from 1962 to 1967. And as well as he is the first vice president of India from 1952 to 1962. And this celebration started when some of his students asked him, and when he took charge as a president in 1962, to sought permission from its celebration to celebrate his birthday as a Teachers' Day celebration. Dear all, since childhood, we have heard a famous Sanskrit quote, Guru Brahma, Guru Vishnu, Guru Devo Maheshwara, Guru Sakshat Parabrahma, Tasmai Shri Guruve Namah, Akhand Mandalakaram, Yaptam Mena Characharam, Tatpadam Darshitam Evan, Tasmai Shri Guruve Namah. Dear teachers, please accept our humble obeisance at your lotus feet. Moreover, Guru is the only ladder through which we can reach all the heights of success in our life very efficiently and effectively. Ever since man is born and as long as he lives on this earth, he keeps learning something every moment. And because of this habit of us humans, we also develop throughout life. When a person stops learning, his development also stops. The first education of a person's life comes from his family, where his mother gives emotional knowledge and his father gives him material and worldly knowledge. Mother introduces him to relationship where his father teaches him how to come out of social relationship and challenges. And during this learning journey, the child has to survive and learn the tricks related to challenges of his life. Thus, he needs a person who has experience and hardness of a father and pampering of a mother who is none other than a teacher. But I would like to point out a word, guru, which we usually come across in Vedic civilization. There is a thin line difference between a guru and a teacher, where the guru recognizes a student's potential and strength. He works on enhancement of his qualities, while the teacher does the work of educating him. In Vedic era, the whole knowledge system was based on spirituality. Then every subject was seen as a connecting every knowledge with God. So people used to have faith in God. But over time, spirituality was replaced by the science, and today we all have started believing more in science. So indeed, science does not believe in God, but still it cannot deny the divine person entirely, even if it bridged built by Rama and the first nautical scriptures written by Rishi Bharadwaja, the first metallurgical expedition done by Nagarjuna and our ancient Urj still, and many more, who was expert in the connecting with them with the mother nature, through their rituals, which we usually call them as a part of spirituality. So we can say that there is always a science embedded into the spirituality, but not necessarily vice versa. Even modern day inspiration by Robert Oppenheimer, who invented the first atomic bomb, who took his inspiration from the Bhagavad Gita sloka from the chapter 11 and slok 32. Kalu asmi lokasya pritya vriddho lokan samahartumi pravitta. The spirituality of ancient India was much more developed than the today's scientific era, and the students always had deep root and respect towards their teacher. They used to learn multi-diversified knowledge through their Shruti Smriti culture. Today, NASA is doing research on Pushpak Viman Shastra, and many more Indian scriptures and science. This is why we have had the status of Vishwaguru, because we have brought more than half of the world knowledge and their significance. We can judge by the burning of Indian sculptures in the Nalanda University for around 6 months. Now India is successfully establishing its existence again in the world. We also need to take science with spirituality, which can never be imagined without teachers and their contribution. Apart from it, there is must miss energy and preservance our traditional knowledge system, which make us culturally diversified country. That knowledge transforms from one generation to another generation with the ladder of teacher, and which should be keep alive. I believe in this journey, teachers have their essential importance and can lead us to our previous status of Jagat Guru. Therefore, teaching will always be a noble and learning profession till the end of this civilization. Because if we don't have Chanakya, we don't have Chandragupta. If we don't have Smat Ram Guru Das, we don't have Shivaji. If we don't have Dronacharya, if we don't have Arjuna, Eklavya, and similarly many more in the modern context, if we don't have teachers, we don't have scientists, we don't have doctors, we don't have engineers, as well as we don't have architectures and many more. I end my word with the famous teacher's quote, our former president, Dr. APJ Abdul Kalam, where he used to believe that there is no other profession in this world which is much more important to society than a teacher. Thank you all.
We talk scientific as an institute of national importance, headquartered Council of Scientific and Industrial Research, Human Research Development Center, Ghaziabad, for the delivery of brief insight into the AcSIR-AMPRI and its achievement, I would like to call our very own nodal scientist, Dr. Alka Mishra.
Hello everyone, respected director sir, senior scientists, AMPRI staff, and my dear research scholars. A very good evening to one and all. Today, on the occasion of Teachers' Day celebration, it's a great honor for me that I got the opportunity to brief about AcSIR-AMPRI. It's only a few years back in 2014 when AcSIR started at AMPRI with just one discipline of engineering and 4 students. Now, in 2022, we have 3 disciplines, physical, chemical engineering in PhD program and integrated dual degree program where students get MTech and a PhD degree. Till now, 99 students have taken admission at AcSIR-AMPRI in different disciplines and 20 have already been awarded their degrees. At present, 76 students are pursuing their degrees at different stages. We have 46 faculties at present who are teaching different courses at AcSIR-AMPRI. All faculties are devoting their intellect and energy for students' growth, taking out their valuable time from their research work and their official duties. Our respected director, sir, has also taken up time from his busy schedule to contribute towards academic activities of AcSIR and has been kind enough to start a cafe coin at AMPRI's campus near AcSIR, keeping in mind students' unlimited working hours and the need for a coffee break. Meanwhile, in 2020, AcSIR approved a highly skilled manpower for AcSIR-AMPRI dedicated for all the works of AcSIR, which is a great support in streamlining the document work since the magnitude of the work at AcSIR-AMPRI has increased manifold since its inception. Through these years, AcSIR has also taken a leap by securing 18th position in NIRF ranking, which means AcSIR has left behind many high-ranked institutions slowly and steadily. Recently, in 2021, AcSIR, in association with RMIT Australia, started a joint PhD program. The students selected for this program have to spend 6 to 12 months at RMIT's Melbourne campus in the final stages of candidature. In this also, AcSIR-AMPRI has opened an account when one of our student of August 18 batch, Mr. Shashank, got selected for 21-22 year. The results of this year's selection is still awaited and we are hopeful to get a good number of selection of our students. AcSIR alumni have also secured good placements after completing their PhDs. University of Groningen, Netherlands, Chonam National University, South Korea, Gautam Buddha University, Noida, Khalifa University, UAE, IIT Kanpur, IIT Delhi, NPL Delhi, SATI Vidisha, Oriental College, Bhopal, and last but not the least, AMPRI Bhopal, where some of our places are some of the places where our students are working as postdoc and RAs. Some students have also got the job in government sector. AcSIR students are contributing in all activities of AMPRI like conferences, workshop, research papers, patent writing, technology transfer. And our students have till now published more than 175 research articles, more than 30 book chapters, have been a part of 10 patents, know-how transfer, received Young Scientist Award at MapCost, received various awards at oral and poster presentation at different conferences and workshops, received NDRC Award. Our research scholars are the lifeline of AMPRI. They are a great energy carriers which make AMPRI campus vibrant. We hope that AcSIR students utilize every minute of their time for their growth, and in turn, AMPRI will attain great heights. Every student should feel their importance for the institute and understand that their dedication and hard work will pay them for a lifetime. I thank each and every student of and all faculties of AcSIR-AMPRI for their contribution towards AcSIR-AMPRI growth and wish all students a very bright future and wish that each one achieves their dream and make all of us proud. Thank you.
Thank you, ma'am. We assure you that we will try our best and do the best.
क्या है, गलत क्या है, ये सबको पढ़ाते हैं आप। झूठ क्या है, सच क्या है, ये बात समझाते हैं आप। जब पूछता नहीं कुछ और, राहों को सरल बनाते हैं आप। With this, I would like to invite our honorable chief guest, Professor Avnish Kumar Srivastava, for motivational address.
आप सभी को नमस्कार. Wish you all a very happy Teachers' Day. We have large gathering, and when I joined here, I started this program of Teachers' Day celebration. I don't know what were happening before that, but I tried to start in 2018 onwards in Sharanjamshala. But then afterwards, COVID came, and then things got disconnected. We have today's speaker online, Professor Yogendra Mishra ji from University of Southern Denmark. Our happy teachers are sitting here, and the big thank to the students who have taken initiative and organized this program. So I think this is first time in my knowledge that students have taken this initiative, and I had a very soft and without showing, I had a little resistance to organize the program in auditorium. But then I could not even show that my resistance because the kind of interest and enthusiasm I saw in the students that I thought that, okay, let it go. We all know that Sir Dr. Sarvapalli Radhakrishnan's memory on his birthday. We celebrate Teachers' Day. And as previous speaker said that since 1962, India is celebrating Teachers' Day. Sarvapalli Radhakrishnan was born in the village called Sarvapalli. That is his first name now, Sarvapalli Radhakrishnan, in Nellore district, Andhra Pradesh. On 5th September 1888. He was a teacher, educationist, philosopher, and politician. He studied the philosophy. And sometimes we go for some course because that is our choice. Sometimes we go because of several other reasons. And when Dr. Radhakrishnan had chosen philosophy as his subject, probably it was not his choice. It was constraint because he got the books, study material from his elder cousin who studied philosophy. So he got transferred all his books, literature of philosophy. So, because he was born in a village and maybe financial constraints or whatever, he took philosophy as subject and he excelled in that. So from that background, he rose up to the highest level of government of India, that is President of India, second President of India, of this independent country. And he served as President from 1962 to 1967. Before that, he was fourth Vice Chancellor of Banaras Hindu University. He was second Ambassador of India to Soviet Union. And he was first Vice President of independent India. So what a great man, having so many credentials, so many positions. He was also the first Bharat Ratna awardee amongst Sir C. Rajagopalachari and Sir C.V. Raman in 1954. That was the year when Bharat Ratna was constituted. So he was among those three. So what a great man. So probably there was nobody else whom we can remember on Teachers' Day to that great extent. And he used to say that teachers should be the best mind of the country. And because of this statement, Teachers' Day is being celebrated. So what we learned from this, that probably irrespective of where we are, what assignments we are given, and in whatever pressure we are, in whatever conditions we are, we should try to do our best without thinking or without expecting the returns out of that. वो आप भूल जाओ प्रोजेक्ट प्रपोजल में आपसे ROI लिखवाया जाता है, that is different thing. But as an individual, when you are working in the system, you should work for the system. You should work for your seniors, and you should work for the future of the organization. You will find that your development is automatically there, because if the organization grows, why organization is growing? Because individuals are growing. Organization is nothing, it's a constitution of all the individuals, starting from the lowest to highest staff member of that organization. Regular, non-regular, technical, non-technical. So that is the kind of commitment we should have for the organization. And I think AMPRI is doing quite good in that direction. And as I think Alka said, that from 4, we are now 92 or 99, and at present 79 enrolled PhD students. So from 2011 or 2013, this course started in AMPRI. From 2013 to 2022, we are now 79 on roll PhD students and integrated PhD students, MTech PhD students. So number has increased. At same time, our publication rate has also increased. And I can see in last couple of years at least, the quality of publications also increased. And then patents increased, number of patents increased. So that's a good sign that we are progressing well. But this kind of sign, satisfaction, should not decrease our growth. We should think something beyond future. What we are thinking, that may not be sufficient, that may be sufficient or may not be sufficient. आज से 20 साल पहले हम कभी नहीं सोचते थे हमारे हाथ में मोबाइल होगा. I remember when I went to Paris in 2000 for a longer trip for 1 year. In India, very few people were having mobile, cell phone. In 96, when I joined NPL, really very few rich people were having mobile. Even in NPL scientists, probably 1 or 2 were having mobile cell phone. And incoming call used to cost 8 rupees per minute. 8 rupees per minute. तो लोग कहते थे हेलो हाय बाद में बात करेंगे, बंद कर देते थे. फिर उनका 8 रुपए गया. उस समय का 8 रुपए शायद 80 रुपए होगा आज. So that was the condition. But I mean, humankind, we only have worked, whether it's in India or US or UK, and from that level, we have come to this level that it is free. You can call for indefinite time. Sometimes that is also not good. Because even if you don't want to talk, the other person wants to talk to you for indefinite time. And then sometimes rudely you have to say, बाद में बात करेंगे. Or you don't lift phone call. Then evening person will again call. And then you will say, oh, it was on vibration, it was on silent mode, or my mobile was not working, I am very sorry. So many things you will say. But the reality, both sides know. So it's a continuous phenomena where we are today. ACSIR came into picture in 2010. I am probably among the luckiest person who have seen the transformation in CSIR, in Indian science, and in world level also. I have seen when there was no internet. Then internet came, and I was not knowing how to use email. That time I was doing PhD at ISC. One of my friends was knowing how to use email, and his professor was having computer in the same department. So how to use his computer? So after dinner, and to be more safer side, after 11 p.m. or 12, we used to go to his room to use email. So in 1992, when I went first time to Chicago, I have to communicate to my seniors, I am coming and all that, arrange my local, all those things. And sometimes you arrange your air ticket from DST and CSIR, 50% funding, this, that. So I have to send mails to him. So I used to, first I have to make my friend happy all the time, at least for 1 month, 2 months, that he will go to his professor's room in the night and he will take me there to send mails. Definitely in the morning in a softer voice, we used to inform to that professor that we are using your account, but not in his presence. So that is the time we have seen. Then computer came to individual's lab, big size computers, and one computer, 6 students, 10 students, then time to time you will get turned. Then you have to start learning. And there is no formal teaching of computer science in the classroom. But we also know how to write software, how to make PPT. And then if there is some small problem, we can rectify. So it's always a learning process. That is how we started learning. Then internet came. Now, internet, I was watching some mails. Sorry to, I should tell, but I shouldn't have done, but I was checking my mails also when somebody was speaking here. So that is where we are, multitasking, if it is required. So again and again, what I want to say that it's a very continuous process of learning, and there is no end of that. And for students, present era students, probably you have missed something which we have seen who are at least above 50 at present. Because that was a real transformation we have seen. So now as a director, if somebody comes to me with some problem, I can assure you more than 100%, I can assure you that I have faced that similar kind of problem at some time of my life. Okay, so you are telling that it's a very serious problem, but since I have faced, so for me it's a very usual thing. So I know when you will be able to come out from that problem, and probably what is the solution. But if I tell you the solution straight away, you may or may not like it. That is another problem. So then most of the time, I have to keep quiet. With time, this person will solve himself. He will struggle with his PhD supervisor, or he will struggle with his HOD, fight with PPD, he will go to accounts, he will go to purchase, he will go to finance. And these are all normal problems, and it will get solved. Sometimes I tell you, there are problems. People say it's impossible. Definitely, I also say that it's impossible. There are anything you can solve under the sun, but within certain constraints. Sometimes you feel your problem is very serious, but for others, it may not be a problem at all. So please try to understand that you are not an individual in the system. You are moving with a team, and that team is nothing but your a larger umbrella family. So you have to cooperate with everybody, and you have to gel with the system, and you should try to perform the best what you can do at your level. There is no competition. You should not fall in competition. If you want to fall at all in any competition, then your benchmarking should be some Nobel laureate. Nothing less than that. Don't try to compete with your colleagues. Then it's not a competition. It gets converted into some kind of fight. Okay. So if you want to compete, you should have a benchmarking of some Nobel laureate at least. Or a person like Dr. Radhakrishnan. Nothing less than that. Then you will find that, yes, your mind is growing, you are growing, and you have a very bright future, especially for students. This place is very good, I tell you. I have seen more than 15 countries. I have seen 2 IITs, ISC. I have seen boarding school, one of the best boarding school of the country. I can tell you this is a very optimized, best place of the country, having international benchmarking, and you are under safe hands. You should enjoy and work as much as possible. Coming back to AcSIR, why it was it got originated? Because we were finding difficult to register our PhD students those days. So Dr. R.A. Mishra, other than DG, he said we should have our own academy. And he initiated this thought, then he involved the then director of IGIB, Dr. S.K. Brahmachari, and director of NPL, Dr. Vikram Kumar. He assigned this task, but during his tenure, this could not happen. And in 2010, when Dr. S.K. Brahmachari was DG CSIR, Lok Sabha, Parliament approved this, and ACSIR got established. And in 2011, it got that the notification of institution of national importance from the then Ministry of HRD. Now it is Ministry of Education. And our first regular director of ACSIR was Dr. Sangwan, just got superannuated. And Dr. Sangwan was my batchmate when I did this CSIR Scientific Leadership Development Program at HRDC Ghaziabad. I think it was in 2006. So some way I am directly connected to ACSIR. And in NPL, I was the second faculty as a teacher who took class in ACSIR on nanostructured materials. It was on 8th August 2011. It was, I think, 10 a.m. to 11 a.m. Second floor. There is also one correlation that may be little personal, but I can share here. Dr. Radhakrishnan's granddaughter's husband, Professor S. Ranganathan, was my PhD thesis supervisor at IISc Bangalore in metallurgy department. So somewhere I am in loop of ACSIR and Teachers Day. But definitely it's a very proud moment for all of us that we are celebrating Teachers Day. काम करिए, मेहनत से काम करिए, खुश रहिए, झगड़ा मत करिए किसी से, और try to complete your PhD as soon as possible. And अपना नाम रोशन कीजिए, घर वालों का नाम रोशन कीजिए, इंस्टीट्यूट का भी नाम आपसे ही होगा, आप लोग जाएंगे तो बताएंगे हम मैथिली से आए हैं. So with all these words, all the best, and thank you for organizing this program. Namaskar. Jai Hind.
Thank you so much, sir, for your motivational and valuable words, sir. We are very lucky to have you as our director. And I assure you, sir, we will try to put these changes in our life. And thank you so much, sir.
Now, I would like to invite Dr. Raju Khan, AcSIR-AMPRI coordinator, for an enthusiastic address and welcoming our invited speaker.
Respected Director, sir, Dr. Alka Mishra, Nodal Scientist of ACSIR, seniors, colleagues, and my dear student, a very good evening. I would like to thank everyone for giving me this opportunity to say a few words on this auspicious occasion. So, Teachers' Day is one of the best days in the life of a teacher. Our students always come up with something special for us. And this Teacher Day is celebrated on the birthday of Bharat Ratna Dr. Sarvepalli Radhakrishnan every 5th of September. But for some reason, we are celebrating today at CSIR-AMPRI. All the scientists and faculties are so lucky to have such great students who make our day really special. And today is also a special day for the Onam festival. I wish you happy Onam to all. Today we all are honored by the amazing function organized by the student. I am glad to be in this profession and get so much love and respect from all of you. I am very much thankful to all students for such beautiful arrangement. and decoration of the auditorium of our institute, and very nice invitation card. Now I'm going to say a few words for our institute CSIR-AMPRI for the kind information of our invited distinguished speaker, Professor Yogendra Mishra, and he is already joined. CSIR-AMPRI is known for its world class status in the area of advanced materials, processes, and component development. The institute has highly qualified and experienced researchers and faculty professionally trained in areas of material science and engineering, synthetic and natural fiber-based composite, smart and energy material, cellular structure material, additive manufacturing, shielding materials, and biomaterial for biomedical and biosensor applications. CSIR-AMPRI is equipped with advanced characterization facilities such as TEM, XRD, Raman, TGA, 3D printer, so on. So very recently, our dynamic director, Professor Srivastav, has created a lot of new equipment facilities such as TEM and also developed a Swadeshi Raman spectrophotometer at CSIR-AMPRI. And infrastructure-wise, for new green building, work is going on. I would like to inform all students, our director is also trying for creating a wonderful hostel facility in the near future on our campus. So more than 82 students are currently working as a PhD in different discipline and working in advanced areas of research material and science engineering, physical science, chemical sciences, and integrated dual degree program are being run at AMPRI Bhopal. So today with us through online mode, our eminent scientist, Professor Yogendra Mishra from the University of Denmark. So on the behalf of Director CSIR-AMPRI and the entire team of AMPRI, a warm welcome to you, sir. Now I'm going to introduce our speaker for the benefit of our students. Yogendra Mishra is a professor of the Smart Material Group of the University of Southern Denmark. He is heading the Smart Material Group with a focus to develop new material for green and sustainable technologies. Prior to the University of Southern Denmark, he was leading an independent research group on 3D nanomaterial at Functional Nanomaterial, Kiel University, Germany. Kiel University was founded in 1665. It is the oldest, largest, and best known university with more than 27,000 students, where he introduced the new flame-based technology for tetrapod nanostructuring, including their 3D high porous network as flexible ceramics. Professor Mishra did MSc in physics from Allahabad University and PhD from Jawaharlal Nehru University, New Delhi. Professor Mishra has published more than 250 publications, which have been cited over 13,000 times with an H index of 63. Top ranked publications are in Advanced Material, Material Today, Progressive Polymer Science, Advanced Functional Material, and so on. He has supervised more than 10 PhD students as well as many MSc and BSc students with more than 12 years of teaching experience in the field of solid state physics, semiconductor, and nanotechnology. And he is editorial board member and associated editor for many prestigious journals such like Material Today, Nano Energy, and many more. He has received many notable awards like Humboldt Fellowship and Young Investigator Award. The list is so long due to the shortage of time. I am not going to all. Professor Mishra is very well known worldwide for his research activity on functional tetrapod-based technology. So now I request our distinguished invited speaker, Professor Mishra, to deliver the talk. Please, sir.
Thank you very much. Greetings from Denmark. Namaste, Pranam, and it's my pleasure and honor to give the talk about our research work on the Teachers' Day. What an honor! I cannot imagine. Are you able to hear me?
Yes, sir.
Okay, yeah. So basically, the image you see is our beautiful campus here in southern Denmark region, and the title of the talk is today Tetrapod-based smart materials for advanced technologies, and I am working as a professor here, and we are Sustainable Development Goal University. But before moving to the talk, actual talk, I really admire Professor Srivastava. Thank you very much for giving such a nice detailed insights about Professor Radhakrishnan. Basically, being living here since 15 years almost in Europe, I feel that I have missed a lot with our history and a lot of developments. I cannot imagine a person to become a professor in those days, 1918 to 20, and I could not imagine what would have been the motivation in those days when India was basically suffering with a lot of things, a lot of problems, and at that time he was coming up with such a strong vision. So I really salute, and this is something what gives us a very strong motivation to keep on working and to keep on kind of learning the things. And thank you very much for your kind of detailed insights about how Professor Radhakrishnan went the career and how he became really a role model as a kind of teacher for everyone, India including the whole world. So it's really nice and good to know that you are also material scientist. I'm very happy that nanomaterials and technology is now at least getting into the market. We are now into the next phase. And this is my teacher's day style basically into the classes. Still, I come from the classical teaching style with the board and the pen, and this really helps a lot. And this was during the corona time, but still we could manage to do that very well. So wishing you all a very happy Teachers Day here. And this is not just the Teachers Day, this is something also a very good motivation and inspiration for us to get motivated with our seniors, our elders all around us to learn something, because something is happening in our daily life and that is changing our life. And it is always, one should always be curious about what is happening, and that is going to improve more or less to everyone. I usually say to my students that you are the best, you are my best teachers, because you are making me a teacher, and that's how it develops. So thank you very much for again inviting me on this very beautiful occasion. It's my pleasure and honor. Well, a little introduction about SDU Sønderborg. We are University of Southern Denmark. It's a quite young university here, and this was established by merging different engineering colleges in Southern Denmark. This part is Sweden and this part is Germany. And here you see we have campuses nearly every city in Southern Denmark region. Despite of being young, this is very kind of very rapidly developing universities, one of the top most and the youngest ones, with a lot of students, employees, and fundings and many graduate programs. We are fully international, and here we are located next to the Germany border, Sønderborg campus. The image you have seen in the beginning. We are focusing on cutting edge material research about and with translational activities in a way so that we can translate our materials to real applications. We have state-of-art clean room facilities and then advanced facilities like helium Orion microscope, 3D tomography, and many other characterization related infrastructures, including the material development as well. Well, what is I have organized the talk in a way that every student should be able to follow. It is a kind of different talk where you see something has been developed out of scratch, and that is already kind of is there into the market with some scopes. We all have been working with nanoscale materials since 30, 40 years, 50 years. And we know very well that when the material becomes very small, their surface to volume ratio is very high. And they hold very nice properties, which are very good for many applications. So we are in the situation that we can develop nanomaterials. We know their properties theoretically and experimentally. We have nice advanced techniques to characterize those materials more or less in a very good way. Even now you can see atom by atom using advanced electron microscope. So we are at the edge where we know this is a nanoscale material, these are nice properties, and we also know that these properties are suitable for this particular application. But what is the fact? Can we go to the market and buy a product which is built out of the nanoscale materials? There is no straightforward answer. It is not a straightforward story. There are, of course, some, but we need to kind of work more on this direction, on the bridge, how to harvest those properties, nice applications in our daily life. For example, if you want to make a sensor out of a nanowire, first we have to make a nanowire, then we have to go to clean room and we have to do integration. And there we get a lot of challenges about, and the overall cost goes high and high. So basically coming from India and coming from normal background, I also started working with nanowires in Kiel around 15 years ago, but was not so happy with the fact that in device integration is taking a lot of time. Then I decided to think something out of the box and came up with the idea while working in the kitchen. The sponge you use in the kitchen, it is a very remarkable material, and it has a lot of inspirations. For example, if we could arrange, I came up with the idea that if we could arrange these nanowires in the sponge form like material, then we have no problem of integration and we can really use nanoscale features at the large scale. And this is definitely a very good motivation. It is a prominent example of how architecture can introduce new properties into the material system. If it was a solid polymer blocks, you cannot bend it, you cannot fold it, you cannot squeeze it. But here it is 1 by hundredth of the amount of the material with interconnected structure. You can squeeze it, you can expand it, you can hold the water, you can release, and you still have access to its surface. That is basically when we talk about nanomaterial, it's just the surface accessibility. So this is the dream material, what I dreamed for, to make a ceramics like this, but it's not a very straightforward story. We can go back and talk in the same way like top down and bottom up approach, but basically both are very, very complicated and not straightforward. I came up with a very simple idea. That's what I'm going to tell here. And our aim has been to develop spongy materials by a simpler process. So what I got inspired and what I introduce when you are walking along Mumbai to the Juhu beach or around, you can nicely see these architectures lying around these tetrapod building blocks. They have four-legged structure at particular angle, and they are lying there not just because of by mistake. They are there just because of certain purpose, because this structure is a perfect structure in a way. The three-dimensional structure does not matter how we place it together. It forms a three-dimensional interconnected network with a random degree of porosity, and this randomness really is a very, very efficient construction. Poor randomness is leading to very nice construction, which is suppressing the water waves, and this is a temporary construction. So I came up with the idea that if we could make these micro nanoscale tetrapods in the laboratory from any material, then I could construct a three-dimensional nanomaterial like sponge or flexible ceramic, what I aim. And this is what the story is all about. This started from scratch, and this is quite successful since last 10, 12 years now. So what we are doing in the lab, we are developing these tetrapods of zinc oxide by a simple process I will show in the next slide. And then we are using them in sensors, photonics, energy, bio, hybrid, and simply catalysis, composites, and many more directions. And that's our small group from the last year photograph. There are some more who joined, and there are some more, some of them have got job already. Yeah, so basically you might be wondering how I developed this process. Again, this is an inspiration of kitchen. If you if you forget something, if your food in the oven, what happens? Our food burns, and then after the burning is over, the furnace oven is completely covered with a black powder like material. As a normal person, one goes and cleans the oven and starts a new food, and believe me, a nanoscientist will never throw it out. If you take it to the Raman microscope, if you take it to the electron microscope, you are going to probably find some kind of nanocarbon. That's how the motivation is. In the same way, in the some experiments in 2008 and 9 gave me a hint that I could use this concept to grow some micro and nano structures. So basically what we do, we fill zinc microparticles and in a sacrificial polyvinyl butyrol, and then we put into the in the crucible, we put at high temperature into the oven and let the process continues around 900 degrees centigrade for half an hour. And what happens, these particles are carried away by the flame, and due to the high temperature they are converted into the atomic vapor. The polymer does not allow them to agglomerate to form kind of larger particles, so they are converted into the vapor, and then we have a growth from the vapor phase. So initial there are several possibilities. If we apply a kind of catcher substrate, then zinc oxide is a material with hexagonal side crystal structure. It has a fastest growth axis along the C direction. That means whenever there is a growth, this will be the fastest growth axis to minimize the energy. So when we apply a catcher substrate, then we could grow wire on the top. But if we do not apply any substrate, then what happens? We have fast growth of simply zinc and oxygen clustering like nucleation, and initial an octahedral nucleus is formed. Then we have a growth along the 6 facets, and that is leading to formation of tetrapod like structure. There all these four 1T structures are quite crystallinely interconnected together at an angle of 105 degrees. Well, zinc oxide is a very robust material. As a comment, I would like to mention here that whatever you do by chemistry, by biological method, by chemical method, whatever, you are going to easily get some kind of 1D micro and nano structures. That is an advantage. This is also a disadvantage, and that's why I usually make a comment: please do not start your research with zinc oxide, because as a researcher, you would like to find something, a kind of a novel point, what is unique I'm going to do. And almost everything is published, more than 1 million papers in this direction. Well, I had the same question in 2010, and I worked on zinc oxide, but I developed this method, and I developed zinc oxide tetrapods, and this is how this method looks like. So this is the process going on into the furnace. This is how the furnace looks like at high temperature, and after the process is over, we take the crucible out, and this is simply filled with white powder, and this white powder is mainly the zinc oxide tetrapod like powder basically. And this is our stuff. I can harvest in large amounts, and every day more or less we produce these tetrapods. And then this process was very well established, and afterwards we had the possibility. So here you see these tetrapods are able to self-assemble themselves into a 3-dimensional architecture, and that is with high degree of porosity. And this really helped us a lot to develop these novel flexible ceramic like material. Even on the top of that, we have the possibility to change the experimental parameters into the process, and we could develop really more nanoscale structures in the same process and in the large amounts. So every process gives us around 5 to 10 grams depending upon the size of the furnace. And so the tetrapod is a very efficient construction. It forms a porous geometry, and we have access to the surface in a very, very nice way. Something you might be wondering, what is more special, here you see the scanning electron microscopy video, that when we imagine one arm, we might imagine that this arm is completely flat, completely smooth from bottom to top, but that is not the case. when we go from bottom to top, then we have lot of staircases structure on the each arm, and that is giving a lot of advantage in the sense that nanomaterial, it is the surface, and every restructuring at the surface is going to contribute additional kind of surface defects. That makes them very, very interesting. Well, how did I make the three-dimensional network? So we take the powder and then we fill into the molds, ceramic molds with well-defined volume and amount we decide. That's how the volume divided by the mass divided by volume is the density. And then we heat again at high temperature, 1150 degrees centigrade. And what happens due to the second heating, the places where these tetrapods, so when we place them together, when they self-assemble, they are touching each other, but they are not strongly touching. Due to the second heating, what happens? We have really formation of interconnections. We have diffusion, which is going on, and that is leading to formation of three-dimensional interconnections and giving the certain mechanical strength. So these are some examples of the tablets 3D networks we can make, and we are flexible in terms of any design and almost any large size. We can make even a brick of several centimeter by several centimeter by several. So that is our novel advantage. Well, what is novelty? Further novelty here, that by tuning the initial density, we have the possibility to tune the porosity of the network. And that in some sense also decides the Young's modulus. All these tablets are having a porosity of around 95% with a density of 0.3 gram per cc. So these tablets are made out of zinc oxide tetrapods. They are flexible. They are having a porosity of 95%. They are inflammable, high temperature stable. They are lightweight and the flexible too. And they are made out of semiconducting material with wide direct band gap. So this is our kind of a development what has been introduced in last 5 to 8 years, 10 years almost, I should say 12 to 15 years. And this is our regular stuff we are doing on the daily basis. Now you might ask where these nanomaterials could find an example. Well, as a general scientist, a material scientist working in the field of metal oxides, N-type semiconductors, what comes first as a sensor device, UV sensing device? Normal sensing device, we have to really make a nanowire, connect it, or a thin film, we have to connect it, then deposit the contact and everything. We came up with the idea that here we can take this kind of network as a bridge, and then we design very nice sensor, which is the flexible as well in this device form, with high porosity access to the bottom from the top. And this we design and we have studied in a very good way the UV response, gas sensing response, and the hydrogen gas response, and many other gases. This worked quite well. But then something more came, that is not only the UV, or we can go to the gases, and because of the high surface accessibility, we can have a better sensing. So we have up to now somewhere the environmental sensing. What became very prominent in since 2019, there is a new virus all you know about has been propagating around, and the biosensing got very important. Viral sensing, whatever. What we realized that these tetrapods also have the ability to bind basically certain viruses, or to interact with the cells and different kind of biological elements, and something coming and touching, that means it is a sensing. So this biosensing is kind of getting important on the daily basis, where we have been working on. What is most important also, an advantage for zinc oxide because of CF non-centrosymmetric structure, hexagonal wood side. If you try to bend the arm, then you are going to generate a piezo potential, and if you carefully connect it, then you have the possibility to use this potential to harvest the energy. So one can design the self-powered devices, and that is an advantage. Yeah. But Apart, there are a lot of advantages. This is the flexible. We can kind of, if the substrate is bendable, then we can also use a flexible sensor, flexible devices. But there are a lot of challenges. Selectivity. Nanomaterial in the lab, we take a particular gas chamber and we expose, then we know what gas we are sensing in, and it works very fine. But what about if I take my sensor to the crossroad, to the railway station, and if it is able to tell basically what gas it is sensing? And there comes the advantage that on these tetrapods, we have the possibility to load selective markers or other nanomaterials to increase the selectivity. And those who are working with zinc oxide, please keep in mind that zinc oxide is not stable in acidic medium. So that is another problem. I will highlight this as an advantage later on. And there are several compatibilities. So this is a good material. This is a good sensing element without any doubt. But we do have a lot of challenges and a lot of further things which needs to be done. And here we have been working a lot. At the moment, we are working with respect to the biosensing more. And there we just wrote a nice review about materials, gases, and kind of atlas. If you want to sense this gas, then which material you should choose. And slowly we are more moving to the early stage detection of cancer and many other diseases. And we are trying to integrate both platforms together so that we have the diagnosis and the treatment, both windows together. Though challenging, but we are moving in this direction. And that is one separate direction. I can keep on talking for a week about the sensing stuff. Another application direction is simply the composite engineering. Starting from the frying pan in our kitchen to all our plastic kind of parts around to the airplane wings, we have some kind of materials embedded into the plastics to increase the strength, mechanical, electrical, optical. We often put some kind of nanoscale materials or fibers, whatever, depending upon the requirement. And we often encounter the problems like that agglomeration, these structures agglomerate. However, these tetrapod elements, does not matter how do we place them, they do not agglomerate, and they nicely form a self-assembled three-dimensional network into the composite material. And this has given us a lot of advantage to use these tetrapods as filler elements. And on the top of that, some more advantages for the composite engineering, designing smart, self-reporting and self-healing composite materials. So using these tetrapods as a filler, we have been able to engineer Young's modulus, wettability, optical, electrical, dielectric, mechanical toughness, and many other properties of the material. Just one example here to highlight. Often, if there is a crack going on the top of the plane wing, then we can definitely go with advanced microscopes and identify it. But if there is a crack propagating inside in the composite, then we have to damage the composite to identify the damage. So if we could put some marker elements inside the composite, if they can give any kind of signal of the material damage, this would be really nice, and this can be done kind of catastrophic, can be avoided. And here we were using a spiropyran molecule. This undergoes conformational transformation. However, how to uniformly disperse this molecule into the composite is a challenging task, because it doesn't make a sense if I don't have a marker element where we have a damage. So we use these tetrapods really to load first the marker element, the spiropyran, and then they were used as a filler material into the PTU matrix. And this matrix nicely showed basically a color transition from blue to many other colors in a nice way. So under the impact of force, light and hammering, it was, and with respect to the heat, it was changing its color. And in this way, we could design nice self-reporting material. We are also now trying to embed self-healing monomer here, so that if there is a crack propagating, there is a kind of polymerization going on at the same time. So you basically it's a self-healing and self-reporting materials together. So there is a lot of scope in composite engineering. We have done quite a lot. I could spend 1 week talking about composite engineering. We have been so successful. One thing which came on the way all of a sudden, and just by no motivation, I should say, to be very honest, we were meeting with colleagues from Chicago, University of Illinois. Deepak Shukla, he's a virologist, and he had seen in some kind of papers that nanoparticles have kind of efficacy against viruses. So he said, Yogendra, why don't you send these kind of tetrapods novel materials and let's check if they have any activity against viruses. And then I send it, just a curiosity, maybe we can publish a paper together if we find something nice. Well, after 6 months, they came back. After 6 months, yeah. After 6 months, they came back and they said, yes, Yogendra, your tetrapods are binding the viruses. So in a simple manner, we have a petri dish where we have cells, and they put the viruses and they try to monitor how many cells are dying and how many viruses are multiplying. And these viruses is heparan sulfate is an enveloped virus. Heparan sulfate is negatively charged. And this goes into the cell via receptors GB and GD via chemical interactions. What happens if we have some nanoparticles in? Some viruses are bound to the zinc oxide and then less are going into the cell. So this really became a big question for us to understand what is the mechanism behind. Yes, we found out by a simple experiment that if I asked them, okay, could you please illuminate this zinc oxide tetrapods with UV light? And then see what about the binding behavior, and they said yes, the binding is now improved. And that was very simple. It is mainly because of oxygen vacancies. You doesn't matter whatever you do, you will have some oxygen vacancies in zinc oxide, and that went more. So we went more in this direction and we could see enhanced binding and everything. So we have studied this in detail. These are the virus structures which are bound to the nanostructures. We went in detail. We have studied herpes simplex virus type 1, type 2, human papilloma virus, adenovirus, monkey virus, murine virus, and herpes zoster. So there's a long list to go. However, one question one should ask very clearly, that what about the cytotoxicity of any nanomaterial? If we are moving into the healthcare business, if material is cytotoxic, then it is not into the games. Often we try to passivate its cytotoxicity by passivating the surface, but then we are kind of compromising the overall properties. And we compared in detail our zinc oxide tetrapods, mainly because of 3D size, have very low cytotoxicity. Every nanomaterial has cytotoxicity. It's just a matter of high or low. Well, to keep this story short, we did a lot of in vitro studies, and then we went to animal studies. We infected mice with genital herpes, which is rather more severe and recurring disease. And then we treated the mice with zinc oxide tetrapods. And here you see the response that the mice treated with tetrapod, they survived really, really long. And here the confocal microscope image, you see the smaller object is the genital herpes virus around 100 nanometer, and this is WBC. So these tetrapods having 3 functions: they bind the virus, they trigger the cell signaling so that WBCs know where to go, and there is certain release of ginkine which promotes the cell growth, and then this way wound healing is much faster. So this was a nice publication and a US patent together jointly, and we did human studies. We got very positive response. We opened a startup company in Germany, at my previous place, and they have launched a cream. And now, if you do not know before, you know from the corona time that zinc is a very important element for our body. It controls more than 200 metabolic functions almost. And if zinc oxide goes into the body, it can be decomposed into the acidic medium. So this is an important biomedical material. Still, it's going on. And we have done quite a lot in this direction. Here is the first product which is out into the market in Germany already. This is antiviral cream mixed with zinc oxide tetrapods. It can be used for antiviral infection. It's just a cream which goes on the surface more or less. So we are very happy about that. Something in 10 years we already have something on the pharmacy to be sold. And well, but I would keep the material orientation a little bit high. Well, I was giving talk at MIT long back ago, and then they were working with these fibers, designing these advanced fibers for more or less wound healing and different treatments. And they came up with the idea, Yogendra, why can't we use tetrapods? I said, yes, I would love to, because zinc oxide is antibacterial, antiviral, and antimicrobial, everything. But they were hesitating to put them into the machine, because the machine they were kind of suspecting the machine is going to be destroyed. So they crushed the tetrapod into the petri dish. So they made really unintentional kind of kinks, structures, and then they put into the syringe, and then the kind of we designed these fibers, and these fibers were used to treat the bacterial growth at the root canal. What really helped, actually, it suppressed the bacterial growth at the root canals, and quite a lot. So that went quite kind of high in terms of applications, and then they were super motivated. And what they did afterwards, these wound healing, the locations after the surgery, we use special fibers to lock the wound and everything. And these fibers, they are biodegradable fiber, PCL and something like. And there is always a question about antibacterial, antimicrobial, anti-fungus, and antiviral infections along the wound side to protect them. And we directly use the tetrapods, and we could design these rose spike-like structures. So the backbone is the PCL fiber, and these are tetrapod arms coming out, and they nicely demonstrated antimicrobial and antibacterial characteristic and antifungal characteristic. Just 1% to 2% is enough to suppress a lot of bacterial growth, E. coli and P. aeruginosa. And recently, we have also demonstrated that they are able to bind and neutralize the viruses so this created a completely new direction towards the fiber engineering for biomedical and many other directions. On the top of that, we also engineer the structure on the surface, and then we bind certain proteins, and we were able to release those proteins with the help of simply green light, which was directly used in an animal study as a kind of together with Harvard Medical School. So I mean, this is the medical. There is a lot in the medical direction. Still, we are learning on the daily basis, exploring a lot. I could again talk weeks, months about the biomedical stuff, but something as the last part, which is most interesting. I do not want to kill too much time of yours. So last part, which is rather motivating and which came accidentally somehow, in a way, in some experiments, we found that these tetrapods are not stable into the chemical environments. And we were using other materials too simultaneously. So what happened that we created a new material out of tetrapods in the same way, and with the same morphology. And this gave us a question that if these tetrapods are so successful, so nice, why can't we grow tetrapod from other material from the same process? And the answer is no, because it is the material which decides how it wants to grow under which experimental condition. It is not the we. Zinc oxide is very robust to grow in this flame approach, but not other oxides. But in using this approach, we decided to use them as a template to deposit a new material on the top, and then to remove underneath. We could grow a lot of tetrapods from other material, and our main focus has been to use them as a sacrificial template or solid backbones to design functional materials and the new materials. So this works in a very simple way. We can take just this one approach as via wet chemistry. We can take any nanoparticle solution, we can drop on these 3D network tablets, more or less, and because of high porosity, this is super hydrophilic, and because of high porosity, whatever we put, it goes to the down completely. It makes an homogeneous wetting. And here we can design composite material into the 3D form with any kind of the combination we want, or later on, if we want, we can remove the underneath zinc oxide backbone, and then we have a completely new material with further high porosity in the same way. So that is totally has been working very, very well, and this has been our main focus since last couple of years. Using zinc oxide templates, we have made a lot of graphene-like materials, carbon materials, fullerene, lot of hard and soft materials, including porous polymers as well. For example, this is PDMS material. So if this, you can see, this is the porous PDMS material which was designed. It has such a degree of porosity. Pores are even sometimes 10 to 15 micrometer long, and the tubes are also hollow because the underneath zinc oxide has been removed, but it is super hydrophobic in nature, more or less. So, and then further, a new material, if desired, then it can be mounted, designing plasmonic composites in 3D or any other magnetic materials, whatever. So we are more focusing on the designing multifunctional materials engineering into 3D form. Then we look for more application scopes. And using this approach, we have nicely made two-dimensional interconnected networks from graphene tubes in a very nice way, where we have tailored the kind of conductivity and also Young's modulus of different these carbon-based material. This is lighter, like it is almost having a very low density. Its porosity is above 99%. It's almost a very airy material. We call them aero materials. They can, if you drop them, they will not fall directly. They will come like a kind of cotton, even lighter than the cotton, more. And they are perfectly black. They have the capability to absorb much more than the Vanta black. Yeah, so as a last some glimpses, we have been using these tetrapods also to design the functional materials. For example, activated carbon on the top of the zinc oxide by wet chemistry, and this was really kind of helping for water purification. We could remove kind of degrade chromium-6 to chromium-3 in a very nice way. This made a very good success. And actually, we were loading iron oxide nanorods on the tetrapods and then interlocking them with PDMS matrix around. And this led removal of basically diesel from water in a very nice way, just with the help of the magnet. And actually, this is the kind of motivation that we can almost put more functions together in such a way that these nanoparticles, any other nanoparticles, are strongly localized. So, for example, nowadays you might be following too much nanomaterials are used quite much into the water and liquid application. We nicely report about photocatalytic decomposition behavior and all other activities, and we nicely publish the stuff. What we do not talk about, that if we leave any nanomaterial fingerprints behind into the water, And believe me, in 1960s, nobody thought of plastics could be a problem. But today, we are having a lot of plastic in our food, microplastics, nanoplastics in our food and water. So by using this approach, at least we are making 1 degree sure not these nanoparticles to recontaminate the water further, which probably could be a next problem in future. And in this way, they could really work as a quite good backbone. So we developed these tetrapods directly for the zinc oxide properties, but then we got multiple opportunities to use them as a novel tool to really kind of mount other nanoparticles, nanostructures on their top in a very good way to harvest multiple functions in an efficiently three-dimensional space. So using this approach, we have been able to develop very nice carbon materials. They have been used as a kind of medical catheters and also cathodes for the high loading of sulfur and supercapacitor as well. We have got a very high energy density of 110 watt-hour per kilogram. That was the highest so far for zinc ion capacitor. Not only the carbon, we have been able to convert almost hard materials to soft materials. So this is a three-dimensional gallium nitride we have basically converted, got from zinc oxide. So we deposited a gallium nitride on the top of zinc oxide into the hydride vapor phase epitaxy process and then etched away underneath zinc oxide. So this is the 3D sponge of gallium nitride, which is very hydrophobic. And if I go inside, look into the electron microscope, the walls of the tubes are like this, more or less in this. So, and in the same way, boron nitride has been converted in a very good way. And we have been using these materials in many different directions. So coming back to the last slide of my talk, that and I would like to contradict myself that if somebody demotivates you to do not work with zinc oxide, still I am the example. I had the same question 15 years ago, and you see the development. So there is a lot happening around us and a lot to go. So I hope I could motivate you to work with zinc oxide. Never get disappointed. Just keep on working. In 2018, I was invited to write a review in Materials Today. More or less, and there we tried to look back the history of zinc oxide and use in the medical use. And believe me, 5,000 years ago in Indian books, it was mentioned that they were using some kind of white powder which was coming out of some burning something as a black powder, and they were using a lot of medicine. And basically, this is exactly the same. So if there would have been internet those times, I would not have been able to patent it and get it. But over the time, we have realized many more applications and many more fundamental properties need to be kind of understood. And zinc oxide on the top of that, it has interesting defect characters. So if we are able to kind of tailor the defect and on this such a three-dimensional geometry, we have much more open scope. So to be very frank, we have very much outlook to learn much more about tetrapods in future. Our motto is research today is technology for tomorrow. It's just a matter of time. Materials are the key component for any technology, and new material creations and characterizations are key to new technologies. With this, I would like to end up my talk. I would like to thank my previous place, Kiel University, Germany, Professor Rainer Adelang, and the Alexander von Humboldt Foundation, DFG Graphene, and many other funding places. I have been mainly developing the materials, and then I have been collaborating with a lot of researchers all over the world, top laboratories, and I would like to thank them. They have been really helpful, and I really like this is a good way to kind of really communicate together, to work together, and to develop together knowledge and applications. And I would like to thank the colleague from SDU Denmark here in Sønderborg and some funding agencies here into the local region. So with this, I would like to say thank you very much for hearing the talk. I hope it was Okay, sorry for taking a little long time, and I am open for any questions. Yeah. Hello. Hi. Hi. Hi, Raju. Hi. Raju, hi. Hi.
Hello.
Hi.
Sir, can you hear me?
Yes.
Thank you, sir, for your valuable words. And I would request all audience if they have any questions. I guess, sir, you have explained very well that there is no questions from our audience. And in future, if there will be any question, we'll come back to you, sir. Thank you so much, sir.
Perfectly fine. Most welcome. I hope it was okay. If there are any questions, please contact me. Thank you. Is that something is finished? Can I go?
Sir, we have a cultural program after this. If you want to stay with us, sir, longer,
No,
you can.
that's if you don't need me, then I will be happy to go over. It's
Thank you so much.
it's totally up to you. Okay, thank you very much. Okay, bye. Thank you. Have a nice day ahead.
Thank you, Professor. आयुषी, ये तो भी ज्ञान की बातें हैं। अब कुछ करते हैं धमाल की बातें। So now let's move forward for the next phase of this program, that is the cultural program. I would request everybody to actively participate. With this, I will pass the mic to Ayushi and Varsha to carry forward the program. Thank you.